Hi everyone, this is Naga. Welcome to my new session. In this session, I want to discuss about how does we empower conversations with the local documents using GPT. Yes, you had me right. So we discuss about how could we empower ChatGPT to converse with our local documents. We accomplish this with large language models like OpenAI, GPT, and LangChain. Let us discuss in detail about this one. With its rise in popularity, we all are aware that ChatGPT has become a global sensation, captivating millions of users. However, despite its remarkable powers, the knowledge it has is limited to a certain date, which is 2021. So it is only trained on publicly available data till 2021. So obviously, if you want to leverage the functionality of ChatGPT in our custom data or in our private data or documents, it's not directly possible. So to achieve that, we use the LangChain large language models and we train it in the sense there are multiple ways. So one approach is training the data set or model. Other approach is using documents as a source and we converse with our documents. So in this tutorial, I'll be talking about how we do the conversation with with our local documents or the corpus of data we have locally or our private data with the powers of ChatGPT. So coming to the overall flow diagram, here we have our large language model where we ask the question and the question is searched with a similarity search on the vector store where all the documents are stored in vector store and we get a response. Let us discuss in detail how it is achieved and what are the detailed steps involved to obtain the conversation with our local document. Coming to the process of setting up ChatGPT with your own data, the process involves two important steps. One is the data ingestion, and the second part is the implementation of chatbot functionality. So let us discuss about the data ingestion. Here, the documents, whatever we have, or the corpus of data is converted into text, and these text documents or text data is split into chunks. Yes, we split into chunks because of the limitation of what we have on the GPT model, where the data has a minimum chunk size limitation that we can check when we are going through the uh, code or the design part. But the documents or the text is divided into chunks of data, and these chunks we create the embeddings in the vector store. So the data ingestion phase can be divided into several sub-steps. So each of which offering great modularity. So let us discuss in detail what are the sub-steps involved in data ingestion. So the first one is loading data source into text format. So consider we have a corpus of data in PDF, documents, OneNote, CSV files. So whatever is the source of data, and also you can have audio files where the audio is converted into a transcript. The transcript is converted into a text, and then it is further broke down into chunks of data, and then we create the embeddings in vector store. So whatever is the data, we try to create the centralitic text data and then convert it into chunks and then create the embeddings and store it in vector store. Then, so the first part is loading data source into text format. Here we focus on transferring the data from various sources into textual format suitable for downstream processing. The second one is the chunking the text. So large language models often have limitations on amount of text they can handle. Therefore, it's very crucial or mandatory for us to divide this text data into smaller chunks which are manageable by the model. The next one already I spoke is text embedding. So we generate numerical embedding of each chunk of text by which it is very easy for the similarity search. So by transforming the text into embeddings, we aim to identify the most relevant chunk that address specific queries. Queries are nothing but the questions we ask. Coming to the next step, we have once we convert the text embedding, we load the embeddings into vector store. So we integrate the embeddings and associated documents into a vector store, and the vector store facilitates the rapid and efficient retrieval of similar test strings based on the embeddings. So let us go through the a detailed discussion or how we achieve with the model. So here we are using large language model, LangChain, GPT. Let me further take you on this discussion. So as we discussed about ingestion of data, let us do a quick deep dive. So loading the data, here if you see we are loading the unstructured data or text data into the document loader. We use the libraries from LangChain, and then we split the data into smaller chunks and store it in the documents object, and then we create the embeddings. So we use the OpenAI embeddings with our open API key. We have our API key. I'll show you in the walkthrough where is our API key and how to retrieve it, and then we store it in the vector store. Here we are using the ChromaDB, and then the last one is querying or questioning on our documents, which is like making conversations with our documents. Let us go through the coding part of this one. So here is the implementation of how we associate or how we create the conversation with our private data or documents of data using GPT. So this is the Python notebook which I used, and below is the code. So these are the LangChain models what we use. This is OpenAPI embedding. Chroma is nothing but the vector store, uh, token text splitter. And here I tried to give an example of various forms of source of data where we convert into chunks of data and we ask the questions. So let us go through this one. Before we start this one, since we are leveraging the features of ChatGPT and OpenAI, the mandatory thing that we need is we need to have one developer account associated to OpenAI, and we need to have our API keys. So this is the secret what I have here, and I will be using this key while I try to do any interactions with the large language model of ChatGPT. So this is a major, but if this how to create the API key, I have posted in a separate video, but uh, uh, this is the prerequisite what we need for having or leveraging the OpenAI API. Coming to the functionality and how we do the conversation of our local documents, I have my Google Drive here where I have some local documents. So let me go through this one. Colab notebooks, GPT search local files. So this store. So if you see here, this is my local store of data where I have text data. These two are text files, PDF data, Word document, and then SESV file. And I do have a Outlook message which I'm trying to read. So know what I'm going to do. I'll try to leverage a the GPT or conversation with these documents. I'll try to ask some general question, and the source of like I want GPT to take these documents as source of truth and provide me an answer for me. So let us get started. So if you see Sachin, this is all about Sachin. So whatever question I ask about Sachin, RGPT would be reading through these documents. It will do a similarity search from the embedding and it will give us a response. So let us go through the walkthrough of how we have got this implementation. So coming to the document here, I'm importing the libraries here, and then this is check install the prerequisite packages. So I have list of packages which I need to install for my notebook. So one is OpenAI, this is ChromaDB, LangChain, TikToken. This is used for text parsing. Config parser, I explain you why I use this one. I have mentioned you about Open API key, right? So I'm storing it in a config file in my store, like in my drive, and then I'm trying to read the key value from there instead of providing the key inline in the code. And unstructured is again one of the module in LangChain. All these are LangChain modules used for document extraction and converting the document data into smaller chunks of data. So here all the required packages are installed for me. Now coming to importing the libraries, the one is OpenAI, which is GPT OpenAI, where I interact for asking the questions in the bot feature. ChromaDB is the vector store. LangChain is the large language model where I use the LangChain feature for splitting the data, converting into chunks, having it in vector store. So everything I obtain with LangChain. So here I am mapping my Google Drive where I have all the text files or corpus of data. So I'm trying to mount the Google Drive to local notebook, and then from here I'm trying to retrieve the API key I have, and then I'll be authenticating my OpenAI API interactions with this API key. So coming to the type of document, I tried to cover as much as possible to import the corpus of text data. So if you see here, I'm trying to leverage the PDF. We are able to convert the PDF data into text and then to chunks and then embeddings. This is CSV file. This is a text file. This is a document file, and this is an Outlook message. So coming to CSV file, here I have some Amazon book reviews. So I would try to ask some question about some review, and I'm expecting some response from these internal documents via GPT. So coming to the functionality, in the ingestion of, so if you see here, we have loaded all the data, and then we have created the documents for LangChain in the format how it is needed to parse this data into chunks of data. Converting this into chunks of data is in next step, but this is the corpus of data where I traveled through the folder and then converted all the document data or CSV data or PDF data, whatever it is, into a common unconsolidated form of text data. Now I'll convert this text data into smaller chunks of data. So here I'm using the text splitter, which is character text splitter, and the chunk size I'm mentioning as 1000 for leveraging the embeddings. Then we create the embeddings using the OpenAI embedding, and this is the OpenAI API key. So we need to pass our API key. We pass a we pass our API key for two things. One is for OpenAI embedding, and then with the large language model for retrieval, where it does a similarity set on top of this vector store. Now here, once we create the embeddings, we have this embedding stored in vector store, which is ChromaDB. ChromaDB we imported from here. So we store it into vector store, and then retrieval, we do a similarity search with k nearest neighbor that we can discuss in detail session. But here we ask the question and we get a response, and we create a prompt for this one as below. So if you see now, I have asked a list of questions based on all the corpus of data what I have. So my first question was, who asked whom to join the school which provided more cricketers? So in the corpus of data about Sachin Tendulkar, it mentions about Archeraker who advised Tendulkar to join. So I'm expecting that answer, and let us see what we got. And I have also asked a question where what causes depression. And since I gave my resume as corpus of data, I just asked the question what certifications Nagamohan have. And then since we have the corpus of data for book reviews, I asked the review of a book called The Outsider. So let us see what response we got. And here we are asking the query which the so this the result, we pass these questions to the QA, which is the retrieval QA. So let us see the question and the response we got from the model. So my first question was, who asked whom to join the school which provided more cricketers? And I got the response, Acharikar advised Tendulkar to shift his school to Shraddhashram. So this is an expected answer, and we are getting what we expected. The second question, what causes depression? So insomnia or sleep deprivation. We have a document where it discuss about insomnia and depression. So we got the answer. And the third one, what certification Nagmohan have? It travels through my resume and it got all the certification I have. So which is also a valid thing. And then the final question, I asked the review about a book, which is The Outsider. So it mentioned about what is the review of the book. It's a positive review. What is the headline? And then more about this book. So uh, we could start and we could empower conversations with our local documents using Open API key and LangChain. So this is an quick intro and shorter session. I would give you a detailed like hands-on session where I would be trying to write the code and in detail talk about each line of code in my further session. But I want to just give you a glimpse of what LangChain is and how large language model and ChatGPT can be leveraged to empower conversations with our local documents. And this is an like a revolutionary feature where for example, if you have any L3 team or anyone, they can just create a bot where it could traverse through all the TSGs and get the responses, which could reduce lot of time and effort, and this is very efficient and useful for us. So wait for my detailed session on how do we do this, and thank you for joining the session.